Hello, good morning, good afternoon. My name is Johan from Fluidtech. I'm pleased to be the moderator of this session today, and also I'm extremely pleased and honored to introduce the next presentation by Guillermo Miró. Guillermo is a good friend of me, knowing him for many times. At the time he was a researcher at Techniker, then he's now an application engineer at Atten2. Um, and they do some exciting developments and products at Atten2. Today he will be sharing and discussing information with us entitled Added Value and Strategies for Digitalized Lubrication. The presentation from Guillermo is recorded, so we will now show you the recorded version of his presentation, and then after that we will have plenty of time to answer your questions. So I'll launch now.
Hello everybody, and thanks for joining this presentation on the Lubrication and Reliability Virtual Summit 2021. And I would like to thank the organization for letting me share our experience in this event. Today we are going to talk about the added value strategies for digitalized lubrication. So we are going to talk about how to extract the most value of your online sensor strategy in lubricated assets. First of all, I would like to introduce myself. I'm Guillermo Miró. I'm currently an applications engineer at Atten2. My background is a PhD in mechanical engineering focused on internal combustion engine lubrication, and then I moved into the sensors field. Now I work for Atten2. Atten2 is a Spain-based company that is technology developer for online oil condition monitoring sensors. Today we are going to talk about Industry 4.0 and how it's impacting on the industry and the maintenance section. According to the US Department of Energy and the World Economic Forum and Accenture, the application of new technologies such as online sensors into the Industry 4.0 journey will benefit the industrial sector in the following aspects. So we can reduce outages up to 35%. We can get a total asset cost reduction of 25% in the complete life cycle. Then, due to the online monitoring, we can reduce up to 12% the planned actions reduction, so extending fluid life or extending equipment drain intervals and so on. Then for sure all these features will result in a total maintenance cost reduction, and then and this is an important significant percentage, 70% of unplanned outages can be reduced due to this application of new technologies, not only online sensors, but they will be part of them. So when we are talking about Industry 4.0 and monitoring, it's important to notice the benefits that they can offer. In which sense can the digitalization of lubricated assets offer benefits? So the first one is a new step or an increase in predictive maintenance applications. So predictive maintenance in lubrication at the moment it's based on periodical sampling, where you get periodical results from a lab analysis and you integrate them into your predictive maintenance practices. The application of online sensor is a complementary tool for this predictive maintenance because this allows you to get an insight of the complete operation of the equipment and correlate it with other predictive maintenance tools such as online vibrations. The big window that the online sensors are offering is the real-time data analysis. So we are moving from periodical points of lubricant data into real-time data analysis. So dynamical data analysis combined with operational conditions, assessing the different environments where the equipment is operating, and so on. Then for digitalization strategies where digital twins are involved, the lubricant condition data stream can help to generate new submodels or increase the effectivity of the maintenance model of these digital twins. And especially for geographically dispersed assets, the online technology can give an advantage because the total cost of maintenance due to the trip, the extra amount of work you need to do to get to these assets and so on. No? So geographically dispersed fleets such as remote power units or wind turbines, for example, are really they can have a big benefit using online lubricant monitoring. Which is the hardware application of these online monitoring solutions? So these are the online oil condition sensors. Okay, at the moment, industry-wide, there are 4 main types of online monitoring sensors. So first of all is degradation sensors. Degradation, there are some talks on the on this event on the LRVS about degradation, so you understand that it's a complex process where measuring degradation is complicated. So the technology, the sensors are using different principles, electrical, optical, to monitor the evolution of the degradation and provide typically an adimensional number of the degradation. The second type and the most prevalent one is the contamination sensors. So sensors are used to monitor solid contamination in the fluid. So typical particle countings based on laser, on optical sensors, where some other features can be applied, such as shape recognition, for example, to get information about wear modes. Then we have moisture sensors that are specifically looking for water contamination, okay, or water-based fluids contamination in the lubricant. So these are focused on measuring, not all of them, but mostly measuring humidity of the fluid. And then there are viscosity sensors that are just measuring this specific physical property of the fluid. So when we gather data from different sensors and we get them like real-time data stream of online condition monitoring sensors, there are several added value strategies that we can apply. So when we digitize lubricated assets, we are able to enable, let's say this way, the creation of new metrics, indicators, and strategies to optimize operation and maintenance decisions. So today we're going to talk about 4 of the added value strategies of the big amount of value strategies that we have applied. So one is what we call static limits and exposure time. Then we have dynamic limits and normality models. Then we have unplanned events fingerprint. And the last one is the maintenance actions assessment. So when we are talking about static limits and exposure time, we are talking about the alarm and alert, let's say, definition. So we can define static limits based on no criteria apart from standards or OEM recommendations. But when we are monitoring online, we can apply the added feature of exposure time. So for example, here we have an example of 2 different particle counts for the same equipment in 2 different periods of time. And here we see the different trends, okay? But then if we apply static limits, we can have static limits such as higher than 500 particles per milliliter. and we can check how much part of the time are we in this alert event. So we are 37% of the time. So this is the exposure time to the alert static limit. If we apply an alarm, we can see how much time we are in the alarm. And then we can create KPIs for this period. We can create specifically for the total maximum particles for the period, the 100th maximum particle content for the period. And if we study the August period, we can see there has been a change in the exposure time. Probably the alarms haven't changed that much if we set static alarms, but if we set exposure time, we can see that the values have increased. So probably there is a change in the wear condition of the equipment or in the contamination of the fluid, but the static limits alone are not effective with online technologies, so it's better to combine them with exposure time. Then, dynamic limits. This is a very powerful tool because now we are able to gather and to combine on operational conditions with sensor data. In this example, we are seeing the evolution of wear particles, big wear particles, together with operational conditions from a gearbox in a wind turbine. So we can see the evolution of the wear particles or the wear particle generation is dependent on operational conditions. So if we see this as a time series, we will see a very noisy trend, but as soon as we apply operational conditions and we filter them, we can create, let's say, safe scenarios. Safe scenarios, what we mean? We mean that we apply limits to different operational conditions. So in this case, for example, in wind turbine gearboxes, there is a, let's say, low noise zone that is typically the design speed of operation for the gearbox and for the wind turbine, where the amount of noise in the wear particle generation is very slow. So we can trend specifically this slot of operational condition or this scenario in a time trend to see which is the affection of wear. So creating these definite dynamic limits based on operational conditions, this will help the customer to ensure there is no noise from abnormal or unplanned outages, so we can see the consistent trend of degradation, of wear processes in their machine, independent of operating conditions. The second step, for sure, it's the creation of normality models. So we can create, for the different operating scenarios, we can create combinations and information about the correlation between operational and sensor data. So in this graph, for example, we have generator speed for a turbo machinery and ISO 14 that this will be big particle generation. So what we can see in the graph, that the normality or the normal operating zone has two different parts. One, it has this part with very low particle generation for a certain speed range, and then there is a threshold where higher speed it's creating higher particles or higher particle rates. So this threshold allows us to create a normality model based in this shape. But we can see values that are outside of this normality model. So we can define, based on tribology concept, if this abnormal zone is secure or not. For example, this zone, it's a secure zone because the wear generation, it's very low, even the speed is high. So this will be a safe spot to operate for the equipment, for the turbo machinery. But there is another aspect that is the opposite, that it's low speed and high wear rate. So if we monitor not just this cloud point as it is right now, but if we monitor the evolution of the cloud point during the time, we will see additional benefits from the normality models. Next step is the unplanned events fingerprint. This is one of the other most important aspects of online technology is that they are always there. So always the technology is measuring and monitoring. So every time it happens an unplanned event, sensor has been monitoring this event. And these events can be treated as a standard, or sorry, as an external event, no? So not get it into the complete trend monitoring, but to establish a different evaluation and indication for them. So for example, in this case, we have a general trend for the ISO code, and here we see the evolution of different modes of the equipment. So the first mode we see here, or the first unplanned event we see here, it's a controller fault, it's called. So we see a typical performance. So we see a peak here, and then we see what it's called another type of unplanned stop, that is user stop. So we see a different evolution of the, in this case, the ISO code. So getting these events studied separately and creating metrics specifically for them will help to understand how these events impact on the system, no, on the severity of them. And the last added value strategy that we can propose, it's the evaluation of certain maintenance actions. For example, a filter change. So if we perform a filter change, we will see a rapid decrease in contamination of the fluid because of the really best condition of the filter. So typically a filter change provides a rapid decrease in wear particles or in contamination of the fluid. So we can monitor filter changes and assure that they have been done well. We can monitor oil top-ups, so we can make sure that the user has introduced the correct amount and the correct fluid into the system, and so on. All this can be done with online technology. So another example is to optimize filtration efficiency. When we are applying offline filtration, in some sectors, typically it's time-based. So if we add monitoring to these offline filtration systems, we are able to create optimizations based on particle elimination rate. So in this aspect, for example, we can define 50% filtration time, 75% filtration time, and 90% filtration time. So as we can see, the evolution of the trend is not linear. So for this specific filtration, we can define where we want to stop, and we can check the optimum point to stop based on data and real-time data. So this is interesting for offline monitoring units where you need to optimize them. So instead of being if you get it in during a week and at the third day you are at 75% filtration and this is enough for you, you have double of time to filter another unit. So this is optimization of asset and maintenance cost for sure. So typical applications of online monitoring and benefits. One of the applications is air compressors. In air compressors, it's easy to monitor lubricant degradation parameters, and in this case, we monitored correctly with our oil health technology 2 top-ups where we saw a decrease in oil degradation measurement, and then we saw a different degradation speed rates. So we saw during August an event, a rate, and during September and October a different rate. So this is due to operational conditions, but in the end, what this will give the customer is the ability to planificate the fluid life or the unquantified operation impact. In this case, the customer extended their life per 4 times when using our technology. Second application, for example, it's gearboxes. Gearboxes are everywhere, but in this case, we're talking about wind turbine units where we were monitoring an unplanned event. So the unplanned event created a big impact on particle generation. So this implant event where was a voltage drop, so the machine was disconnected from the grid, so it was forced to stop. And we saw 3 voltage drops where you can see the trend of in ISO code and particles was very low. And as soon as this event started, the peaks for ISO code were higher. They increased a lot, so even multiplying per 5 the total amount of particles generated at the last event. Then the machine went back to normal, but in a different wear stage. So we recommended, or the situation was irreversible. So we recommended some actions for the customer to reduce the impact on this event before the planet outage. Okay, so this is interesting because you can win extra operation time, you can do some up tower repairment instead of down tower, so you are earning a lot of money. Then you can reduce some other maintenance tools such as boroscopies. Hydraulic systems are also benefited from online monitoring. So if we are using hydraulic systems in a dynamic way, we can see the influence of filtration. So in this case, for a hydraulic unit, we measured the same process without filtration and with offline filtration, and we checked how much life it gained. So based on Noria's approach of fluid or asset life based on cleanliness, we defined the initial ISO code and the final ISO code. So we gained up to 2%, or we multiplied per 2 the lifespan of the equipment based on a low cleanliness code. So online monitoring can help you to assess this life extension based on low or clean oil. And the last application is turbo machinery. Apart from the typical features, here we were assessing unexpected events. So for example, this is an start event, so we were able to create KPIs for particle generation, for bubble generation, and for wear mode particle evolution, because we saw a different trend in the different wear modes or particles that were generated. So sliding wear, fatigue wear. So monitoring this and creating metrics for this, it's important for this application. So digitalization is the current paradigm and requires data and technology, and maintenance is no exception for that. So the gap between oil analysis and Industry 4.0 is being covered by online sensors because they are creating digital data. Okay, then the generation of this data, it's embedded into the news information sources that the asset has, such as SCADA system. So we can get this into the asset intelligence system and create new perspective for the customer in terms of OEM decisions. The for sure real data analysis is generating new criteria, more dynamic, new visuals, and new ways to understand the information. And for sure, the online sensor technology is allowing a better monitoring of operational risk and the increase in reliability and efficiency of the industrial machinery. So thank you very much for your assistance, for your time. I would like to thank again LRVS for letting us share our presentation. And now let's get some questions if possible. Thank you very much.
So, thank you, Guillermo, for this interesting and I would say clear presentation. For me, it was interesting because every time I understand a little bit more about how realistic IoT and sensors are. and it's not just a dream. It's not just something which is there, but it's available as a product. And I'm also I must say that as part of this whole discussions panels I've heard about sustainability, it's clear that if we want to move to a maximum lifetime of lubricants, it's clear this IoT will also be very important. I have no questions here. I see no comments, but I have a question. Is that I think because I'm very much involved with OEMs, and
Mm-hmm.
um, how can we make sure that we move them also in that direction? What is your experiences with them, and just to make them, I would say, moving into the direction of online sensors? What's your
Mm-hmm.
experience with that?
Thanks, Joe, for all the introduction and this question.
Yeah, yeah,
So regarding OEMs, I think they kind of they are some of them are aware of the benefits of this technology. In fact, we are working with OEMs in different sectors, and they are applying our technology in a more advanced way that I have talked here. No, so this presentation is just let's say the tip of the iceberg in terms
yeah,
of added value strategies. No, but as soon as as you mentioned, it was commented yesterday. No, so as soon as you have operational data, maintenance data, and other data streams, you can you can have a lot more insights about the asset condition, and the online monitoring has a bigger benefit. But for sure, end users can benefit directly from sensors, but OEMs are highly interested in these solutions for sure.
yeah. Yeah, because I think especially now with Corona, I noticed that a lot of OEMs they bring like VR technology on site
Mm-hmm.
for people to be getting data from the field. And but I wonder. I mean, it should be so easy then just to gather more uh, um, equipment data via this IoT. So I expect a lot. I think now after what happened with during this last months, and so that OEMs are going to move also more and more in IoT, and so that is certainly a good. Um,
We are focused on, I mean, we are flexible in this situation. No, another comment that was done yesterday, I remember in the Jorge Alarcón presentation, it was
uh,
the data governance. No, and this is important
yes.
for OEM. So in our case, as we are focused on a, let's say, on a really good relationship with the OEM, so we are
Mm,
happy to share them our expertise. We are, I mean, we are some engineers in the company that are learning from the sensors and what is happening to the equipment, and we are happy to share our expertise with the OEMs. And but in the end, they are the owners of the data. We can help them,
mm.
but the owners, we are not using any platform and so on, and we are flexible in that. We have our own solutions, but they can use their own solutions. So I think this is the way, no, being flexible to fulfill customer demands, no, especially OEMs.
Yeah, and I think uh, yes, it's a good point. At the same time, industry is really requesting. I insist on that. Is this longer lifetime of lubricants, and
Mm-hmm.
at the same time, there's more stress, and so this realistic data generation is so important for them. So. Okay, it was a good discussion. I had hoped to get some more questions, but I think people, it's maybe a little bit too early still. I don't know, but it was a good presentation, Guillermo. I learned a lot about it. I'm
Thank you, Joe.
fascinated. I'm fascinated about this, and this presentation will be also recorded and available. But um, Guillermo, can you do me a favor and send me just by email, is it possible, your PDF presentation?
Yes, for sure.
Because I receive so many times, I'm a lot of time on site, and then I can always forward it to people who request me something on IoT. You have my email address, Guillermo?
Yes, yes, yes. You, I have it from the training session we did in Eibar last time. For
Yeah,
sure, I
yeah,
can have it. So
yeah. Top. Okay,
thank you,
good.
Joe.
Enjoy. enjoy the LRVS to anybody who's listening, and have a nice day. Thank you again, Guillermo, and all the best.
Thank you, Joe, and
Back
also
to
the
the
audience
next
for
session.
attending. Bye bye.
Yes.
Thanks.
Bye bye. Thank you.
Bye.
Bye.